Okay, in the last video, we were ever so close to solving this integration problem here. We said the whole thing hinged upon letting x be equal to z squared. And when we did that, the integral transformed into this, and then we used long division and split it up into these two integrals. This one we could integrate right away. And even though this one didn't appear to be in the standard form that would be amenable to a trig substitution, we tried it anyway because we had this z here, and also we said, well, if we're going to call let z be equal to the tangent squared of theta, obviously that would be a secant squared. But when we take dz, we're also going to get a secant squared, and that might cancel with this, so maybe it'd work out okay. So we went ahead and made the substitution, and it did work out okay. What we ended up with this integral here, 8 times the tangent cubed of theta. So this integral here gave us this, and we could whittle that down into these two integrals, which we could integrate right away. This is the tangent of theta times the secant squared of theta d theta. If I say let u be this, du is going to be the secant squared of theta d theta. So that's just an integral of u du, which is 1/2 u squared. So the tangent squared of theta, 8 times 1/2 is 4. So that was pretty simple. And the integral of the tangent of theta is minus the natural log of the cosine of theta, so that makes a plus sign here. And with our substitution, z is the tangent squared of theta. We know what this is going to be, and we have to find out what is going to be the cosine of theta in terms of z. So we go ahead, we draw a triangle, and the tangent of theta that's going to be the square root of z. So the square root of z divided by 1. The tangent of theta is the side opposite divided by the side adjacent. So we know what the hypotenuse is. So the cosine of theta is the side adjacent divided by this. So this integral here gave us this, and then we also had this minus z squared from this first integral. So we wrote them all down together. And we have to remember now, z is going to be the square root of x. Now, here, 8 is 4 times 2. 2 times 4, we can take the 2 to this exponent here, for what's inside the logarithm. That's just one of the basic properties of logarithms. So then here we'll have minus z squared plus 4z plus 4 times the natural log of this squared. 1 squared is 1. This square root sign goes away, and we have z plus 1. And we can do one more thing before we substitute for z. So here we have this equals minus z squared plus 4 times z, and here we're going to say minus 4 times the natural log. Well, this is now upstairs. Okay, now let's go back. X equals z squared. So this will be minus x plus 4 times the square root of x minus 4 times the natural log of z is the square root of x plus 1. And this, plus an arbitrary constant then, is a solution to this integral here. So, hope it wasn't too long and convoluted, but we are trying to approach here how to handle some of the more difficult integration problems. And we have a couple more videos left where, again, we try to tackle some of these more difficult integrations where you have these radical expressions incorporated into the integral sign. So if you have time, come back and join us, and we'll try and solve some more problems.